Hello students, good morning, good evening and good night, depending on which time you are going to observe this lecture. Welcome to the 7th lecture on electrochemistry. In this lecture we are going to discuss the electrolytic conduction of the electricity in the electrolytic solutions. It is called the electrolytic conduction. So, heading of today's lecture is electrolytic conduction of electricity. So in this lecture we are going to discuss a very important topic, that is the electrolytic conduction of electricity. So far we have discussed different type of cells in the previous lecture, and also we understand how the chemical energy are converted into electrical energy with the spontaneous redox reaction. What is the arrangement? This arrangement is called galvanic cell. How the electrode potential has been developed, how we can able to calculate the cell potentials, all the things that we have discussed in the previous 6 lectures. In total 6 lectures will already been discussed in this topic, and we have understand different aspect of this chapter as per your syllabus. So when we are talking about the flow of electricity, that conduction of the electricity through the electrolytic medium, that we are going to discuss. But before going to discuss this, we need to understand some terms, the definition of the terms, that will help to clear your doubts, clear the concept more clearly. So this is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. First, that is a very important definition of the term, that is the resistance. So first term that we are going to discuss, that is the resistance. So what is a resistance is basically can be explained by the Ohm's law. Ohm's law says that when suppose there is a conductor, and in the conductor if we put the voltages with the one end to the other end, we put the voltage E, and there is a flow of current I. At that time we can say the electrical resistance R. Electrical resistance is represented by R, and it will be the ratio of these two things, that is the potential difference. E is the potential difference, PD, potential difference, and I is the electric current flows. Electric current flows. So I is the electric current and E is the potential difference, and the R is the resistance, that is the ratio of these two things, that is the potential difference to the electric current flows to the conductor. This is represent the unit, it is measured, you can write, it is measured in a very important and well known units, that is called ohm, and its symbol is very important, that is this. So it is measured in the unit ohm, and it is symbol is this, and as the basic SI unit basic SI unit of resistance. Basic SI unit of resistance is equal to the kg meter square divided by A square into S3. That we are going to understand how this basic SI unit of resistance comes. Here this is, you can see kg is mass, L is the length of unit of the length, and A is the ampere, the unit of the current, and S is the seconds. How all these terms come, let us understand. We have to come from the very basic things, that is from the Ohm's law, that we know R is basically the potential difference, means voltages. So we can write it is the voltage divided by electric current. Electric current means ampere, electric current flows. Again, we know voltage is the work done by a unit charge. So we can write work done per unit charge. This is called the voltage, and divided by electric current. We know the SI units of the current is E, ampere. So this can be written like this. Now we can transform this expression in this way, that is work done divided by charge, because it is in a unit charge, and this is 1 by A. And we know work done is what? Now force into distance. Suppose force is F and its distance is L. Force into distance F into L, and charge we know, that is, we can say ampere into time. Time, the unit of the time is second. So we can write A into S divided by A by L. Now force we know, again we go to the basics of this force. What is force? The force is basically mass into acceleration. So we can write that SI unit of mass is kg, and acceleration we know, that is the mass, that is the length per second square. So the unit of the length is meter, and divided by x square, and this is A into A S, 1 by S. So we can put this S here. You can put this S in the denominator, that is kg into, and here is L is another L is there, that you have not considered, that is M. M is basically the unit of the length. So kg M square by A into S square. A is there, another A square into S cube, and this is the basic unit. So you see these units has come from the basic from this, that is voltage per electric current flows, that is the ampere. From this we can derive this. Okay. So now we understand this is the resistance. Resistance is very important property of a conductor, and it has been, you can be able to measure. Suppose there is a unknown resistance of a conductor, you can easily able to measure by a instrument. This is called the Wheatstone gauge, that you must probably studied in your physics. And this is the resistance is a very important property, because from the resistance we will go to the conductance. So another term comes, that is conductance. Conductance is basically the inverse of resistance. Conductance is basically inverse of resistance. Means if the conductor resists much to the against the flow of the electricity, means it is not conducting, it is not allow the current to flow through it, so its conductance will be less. So we can write the conductance, it is the inverse, it is the inverse of resistance. Conductance is inverse of the resistance, and it is represented by the letter that is G, and so we can write G is equal to 1 by R. So naturally the units of the G, what will be the unit? Unit is the ohm inverse, or we can write with its symbols inverse. Another unit of this conductance is the Siemens. Siemens, that is represented by S. Okay, so this is simple thing, that is conductance and resistance. But from this conductance and resistance, another two terms that is much more important, this is that we are going to understand now. Another two important terms we will define now, that is, one is the resistivity, or it is also called specific resistance. And it is represented by rho. So how to define this resistivity? R is basically, resistance is basically the proportional to the length of the conductor and inversely proportional to the cross section of the conductor. This is the length, this is length, and this is cross section of the conductor. So we can have a proportionality constant, that is rho, and this is called, this rho is, this is a Greek word, rho is called the resistivity, and it is, as per IUPAC, this term is much more applicable, accepted, so we will use this, but it also can be said a specific resistance. So we understand resistivity is this is a proportionality constant, and how to define it, let us understand. When L is equal to 1 meter, and A is equal to 1 meter square, at that time when we put these two values, we will get R is equal to P. Means resistivity is nothing but the resistance of the conductor of 1 meter length and 1 meter square cross section. So we can say resistivity is basically a resistance. Resistivity is basically the resistance of, we can write here, resistivity is resistance of a conductor having length of 1 meter and cross section is 1 meter square. So this is the definition of resistivity. So what would be the unit of the resistivity? Let us understand. From this we can able to understand. So we can write this equation in this way, that is resistivity is equal to R into cross section divided by L. So we can say R into L, because cross section, if we consider for the time that it is a cross section of this is rectangle. So we can write the L is the L square is L, a cross section is L square, so it will be L. So the unit of this resistivity will be, because unit of this resistance is R and unit of the length is meter, so we can write is units. Units is units ohm into meter, ohm into meter, or another that we frequently use, that ohm centimeter. What is the relation between this? 1 ohm meter is equal to 100 ohm centimeter. Okay? Or we can say 1 ohm centimeter is equal to 0.01 ohm meter. So this is a unit of the resistivity and definition of the resistivity that we understand. Now we are going to discuss another very important thing, that is the conductivity. We are going to discuss the conductivity. Conductivity is the reciprocal. We can write reciprocal of resistivity. That is, and it is represented by kappa, K. K is kappa, that is the Greek word kappa. So we can write the conductivity is 1 by rho. Conductivity is 1 by rho. So how do we define this conductivity? Let us understand. So already we know, in the previous we have discussed that we can write, we know that R is equal to proportionality constant into L by A, right? From this we can see that rho, that is the resistivity, is equal to R into A by L, right? So we can put this value here. So what we get? We get another equation, kappa is by R into A by L, or we can write 1 by R is equal to L by A. So 1 by R is what? That is a conductance. So we can write G into L by this. Okay. So kappa is basically A. This is G, that is a conductance. This is basically the conductance. And this is the length of the conductor, and this is the cross section of the conductor. So you can say kappa is basically related. How it is related to the conductance? This is G is conductance, L is the length of the conductor, and A is the cross section of the conductor. So how to define the conductivity? As we have defined the resistivity, that is specific resistance, it is also be called the specific conductance. It can be also called the specific conductance. specific conductance. This is also called the specific conductance. So how do we define? That you can yourself define it. How? Now this is basically, conductivity is basically the conductance. How do you say that? When L is equal to 1, A is equal to 1, suppose 1 meter, and 1, suppose it is 1 centimeter, and this is 1 centimeter square. So at the time we put this value, where K is equal to, already we divide that G into L by A. So when we put this, it will become G. Means it is the conductivity is basically the conductance of the conductor, which is having the 1 meter length and 1 square meter per section. So you can write this conductivity or specific conductance. Conductivity is the conductance of 1 meter length of the conductor, 1 meter length of conductor, 1 meter length of conductor, and its cross section. Cross section is 1 meter square. This is called the conductivity. Okay. Now what will be the unit of the conductivity? That you can easily measure that by the units of the conductance. So what will be this? So you can write this G by L. So this will be when the conductance, because this unit of the conductivity depends on the conductance and the length of the conductor. So if it is a Siemens, then unit of the conductance is Siemens, then we can write conductivity K is equal to Siemens per meter, S per meter, or we can write S per centimeter, or we can write another that we can see, that is the K is equal to, we can write ohm inverse, that we can write, or we can write ohm inverse centimeter square. So these are all the units of the conductivity. So far we understand very important thing, that is the resistance, conductance, then resistivity, and then conductivity, and we also understand its units also. Okay, we are going to understand about the conductor and about the insulator and about the semiconductor, about the superconductor. It has been observed that conductivity of the substance has varied from a wide range. From a wide range means as low as you can see, if you see the substance, that you can observe the conductivity. We can observe the conductivity varies. Conductivity varies from, you can see, that is 10 to the power minus 16. That is the conductivity of the glass, right? And the conductivity of a silver, that is, you can write 6 into 10 to the power 3, 10 to the power 3, that is Siemens per meter. It already we understand units is Siemens per meter, this is Siemens per meter. Okay. So this is a wide range that you can see 10 to the minus 16 to 10 to the power 3.
this is for the silver. So there is a widespread variation, so it is required to classify the substance in terms of the conductivity. How? Now, number one classification, that is the conductor. Conductor we know that it is very easily. So conductor is that substance which allow to flow the electricity through itself. This is the conductor, and conductor we know that is metal or carbon black. For the non-metal also you can that have been behave as a conductor, or graphite, or sometimes polymers. In nowadays some polymers you can show, this is also are conducting, and for that also a lot scientists has been awarded Nobel Prize. So metals, carbon black and the graphites are basically the conductors. They allow the electricity pass through. Second classification, that is non-conductor. Non-conductor, or you can say insulator. Insulator, this is like your glass, like your Teflon. All are non-conducting because their conductivity is very, very less. That you can see 10 to the minus 16 Siemens per meter. It's very less conductivity. That is why they are non-conductor, or you can say insulator. Number 3, that is a semiconductor. Semiconductor basically they have the conductivity between this conductor and the non-conductor. This is called semiconductor. Example, that is germanium, JEE, silicon. These are all the semiconductor. Their conductivity is around 10 to the power minus 10 or around these two, around this will be less. And another classification that is very important, that is a superconductor. Superconductor means they have zero resistance. Zero resistance means what will be the conductivity? Conductivity is infinity. So superconductor will conductivity as infinity conductivity. So this is the 4 classification that you can see, but we will be concentrate only on the conductors. Conductors are basically 2 types. You can see one, that is the electronic conductor, that we will discuss. Electronic conductor, or we can say metallic conductor. Electronic conductor, or it is also called the metallic conductor. This is like metal, like the copper, like silver, like these, all these things, they will pass the electricity through this. This is conductor. Then second thing that we will understand, that we are going to discuss, that is the electrolytic conductor. That is we are going to discuss electrolytic conductor. So there is a 2 types of conductor. You can see one electronic conductor, other is electrolytic conductors. Okay, so we will finish here, and the next we will start from these electronic conductor and electrolyte conductors. What is the difference? What are the factors going to affect? That we will discuss in the next lecture. Hope you understand all the points that is as per your syllabus. If you have any doubts, you can comment in the comment section. Thank you for watching these lectures, and if you like this lecture, you can share to your friends. And this is basically a free service to the students of the class 11 or class 12 chemistry, because everybody cannot afford these costly tuitions. So I think this type of lectures that will help them clear their concept and fulfill their aspirations for the IIT, JEE or passing the board exams. That is all for today's lecture. We will meet in the next lecture. Thank you very much.